Integrated Math 7-8 students, we are working on Module 14, and this is Lesson 12. And Lesson 12 is called Linear Equations in Two Variables. Let's make this a little bigger so you can see. Today we will use tables to plot linear equations on a coordinate plane. The question that I want you to be thinking about is, what do independent and dependent variables represent when working with the coordinate planes? So what we need to do, first of all, is we need to learn the names of two new equations that you are going to be using, and you need to be able to recognize them by name. And so one of them is called slope-intercept form. And what slope-intercept form is, it's an equation that actually is a standard form equation that was just changed around so that we're focusing on what the y value would be. So basically, the slope-intercept form is y equals mx plus b, and this form is used to show how to find the y. And so basically what you need to know about slope-intercept form is it tells you how to find the y value, given the x value, the rate of change or the unit rate, and this little b. This little b is kind of important. So basically what I want to go over with you with slope-intercept form, y equals mx plus b. So this obviously is the y coordinate. Okay. I don't even know how to spell coordinate. Coordinate. Sorry. Coordinate. That doesn't look right at all. And the m, as you already know, is the unit rate. Okay. And the x is the x coordinate. I don't know why I can't spell that, coordinate. And then this one is very important because what this b does right here is it symbolizes that extra information that we've been working with for the last couple of days. Like, for example, if you remember back to the yoga studio and there was a $16 startup fee or a $2 startup fee, that's what this value right here represents. And it actually tells you, what this value right here tells you, is it tells you where your line on the graph crosses the y-axis. Okay, so this is actually called the Y-intercept. Okay, and it's very important that you remember that because that is kind of like a double check for you that if you graphed it correctly, it should have fallen on the whatever this number, this numerical value is, on the y-intercept. So that means the x would be 0, and then this b tells you what the y value is. Okay, and so if we're looking at this one, we have y equals negative 3x plus 4. So basically what we would do is if we graph it, it's telling you that it crossed the y-axis at 4, so that means that we're at 0, 4, so you go up 4, 2, 3, 4, and you put a dot. And then the slope, or the unit rate that we see right here, is the unit rate is saying that you go down 3 and over 1. So you're going to go 1, 2, 3, and over 1, and then you're going to go 1, 2, 3, and over 1. And so what you can see is when you graph the line, that's what it looks like, and it crosses right there on the y-axis at this value, which happened to be 4. Okay, so this is called slope-intercept form. You're going to learn more about it, all right? Standard form is the other type of equation that you have to be aware of and that you need to know how to recognize. And standard form, this form is used to show a situation. So basically, let's look at it over here. We have ax plus by equals c. Now, what the a represents is the coefficient of any value. Okay? The x is giving you the x coordinate. Again, sorry with that if that spelling is wrong. This is a coefficient also with any numerical value, and then this is the y-coordinate. Okay, and then C is the value that it equals, which is also a numerical value. All right, and so it basically is telling you a specific situation. So, for example, we have 3 x's plus 1y equals 4. And so you're trying to solve for both x and y, and you'll have to figure it out by plotting the points on the graph to find it. So then the other thing that you need to be aware of for this, because remember our goal is today we will use tables to plot linear equations on the coordinate plane, is that this standard form equation right here can be turned into slope-intercept form just by moving parts around. And so the question that I want you to look at right here is it says, can you turn y equals negative 3x plus 4 into 3x plus y equals 4? So let's see if we can. So we're taking negative 3x plus 4 equals y. I wrote it backwards, sorry. So the question is, can we take this and turn it into standard form? And you'll notice in standard form that the x and the y are on the same side, and then the constant value is on the other side of the equal sign. So if we're trying to change this into this, then we need to move two things. But in order to move something, you have to understand how it's being attached. So if you're looking at this, we have a negative 3x plus 4. So to unhook negative 3x from the plus 4, we're going to add 3x to create a zero pair. And what you do to the other side is the same thing. So we're going to add 3x. And when we do that, we're left with, this is a zero pair. So now on this side, we have 4 equals 3x, because we're adding it, plus y. And now let's look. Is this in the same form as this? Look at it. 3x plus y equals 4, 4. So we just did it. We turned it into each other. So basically, standard form and slope-intercept form are identical equations. The only difference is in slope-intercept form, you're solving specifically for the y. In standard form, you're solving specifically for a situation, okay? And that's the difference between the two. So then the last thing that I want you to try is it says, if x equals 2, what would y equal? So I would say for this specific question, I would use the y equals negative 3x plus 4 because I want to know exactly what y equals. So it tells me that x equals 2, so I'm going to say y equals negative 3 times 2 plus 4, and let's see what happens. Negative 3 times 2 is negative 6 plus 4, and that equals y. And then simplifying it even further, negative 6 plus 4 gives me a negative 2. So the answer is when x equals 2, then y in this specific scenario has to equal negative 2. And then you would graph that on the graph, and that's the answer. Okay? All right, so a lot of new information, a lot of fun stuff to check out. It will make more sense when we have some coordinate planes and some extra practice in class tomorrow, and make sure that if something's not super clear that you ask questions. Today we will use tables to plot linear equations on a coordinate plane. What do the independent and the dependent variables represent when working on the coordinate plane? It definitely depends on the scenario, okay? And then the new information you learned about was slope-intercept form and standard form. All right, that's all I have for you today, kiddos. Talk to you soon. Bye.